Assalamualaikum. For this 02 concentric tube heat exchanger, Thermo 3 heat exchanger. Okay, for this subject, our lecturer is Nurizatul Atika binti Rahmat, and our group member is Muhammad Husani Azhar bin Muhammad Harif, Muhammad Ridwan, Muhammad Rizami, and Muhammad Faris. Okay, for introduction, heat exchanger be classified according to their flow arrangement. In parallel flow heat exchanger, the two fluid enter the exchanger at the same end and travel in parallel to one another to the other side. In counter flow heat exchanger, the fluid enter the exchanger from opposite end. The counter current design is most efficient in that it can transfer the most heat. In a cross flow heat exchanger, the fluid travel roughly perpendicular to one another through the exchanger. For efficient heat exchangers are designed to minimize the surface area of the wall between the two fluids while minimizing resistance to flow through the exchanger. The exchanger performance can also be affected by the addition of fins or congregation in one or both directions, with increased surface area and make channel fluid flow or induce turbulence. Okay, for the objectives, first to study the influence of volume and mass flow rate on heat exchanger performance, to analyze the most effective heat exchanger configuration, parallel or counter flow. For the methodology, the switch on the heat exchanger is switched on. The temperature is set to be 60 degrees Celsius and had been constant for both flow experiments. The water inside the water heater is allowed to be heated until it reaches the required temperature, 60 degrees Celsius. The National Instrument Data Acquisition System was opened and set up according to the data required to be obtained. The delay has been standby and synced with NIMEX data acquisition system to broadcast the output data systematically. The configuration of the heat exchanger was set up as parallel flow and the cool water pipe has switched on. The experiment start with the flow rate of the heat water and cold water was set to be 3 liters per minute, and then the temperature was allowed to reach until a steady state and wait for 1 minute before the reading was recorded. The result obtained was recorded and tabulated through Microsoft Excel and Desilet software. And then step 8 to 10 were repeated by changing the flow rate to 10 volume per minute and 40 volume per minute. And then step configuration of the heat exchanger was changed to counter flow, and step 8, 9, 10 and 11 were repeated to obtain another set of data for this counter flow configuration. Okay, for literature review, heat exchanger is a piece of equipment built for efficient heat transfer from one medium to another without affecting the other property of the medium. The medium is separated by a solid wall so that they can never mix. They are widely used in space heating, refrigeration or conditioning, power plant, chemical plant, petroleum refineries, natural gas processing, and sewage treatment. For the flow arrangement, there are two primary classification of heat exchanger according to the flow arrangement. Parallel flow, two fluids enter exchanger at the same time at the same end and travel in parallel direction to other side. Counter flow, two fluids enter the exit different direction exchanger at opposite end and flow in different direction. For the experiment setup and equipment, heat exchanger, complete with pump, thermostat, and flow rate. For Uniflow, okay, for experiment procedure, heating of hot water tank, check water level in tank and top up if necessary, switch on master switch, set desired hot water temperature at thermostat, and then switch on heater, heating from an ambient temperature of 20 degree until 60 degree, required appropriate in 20 minutes. Okay, for the experiment method, counter flow measurement, first open the ball valve 2 and 4 while close the ball valve 1 and 3. Cool water now flow through the heat exchanger in counter flow mode. And then switch on the centrifugal pump and set the hot water flow rate V1 to 50 liter hour. And then adjust the cold water flow rate V2 to 25. And then wait until the thermo steady state condition is established. And then enter the temperature, T1 to Tc and hot water flow rate. And then repeat step 3 and 5 by 3 to 5 by vary the cold water flow rate. And then repeat the experiment by adjust the hot water rate. Switch off the heater, centrifugal pump and cold water supply after the experiment. Draw the average temperature profile with varying the thermometer location in the same graph for hot water flow rate and cold water flow rate. For Uniflow measurement, open the ball valve 1 and 3 while close the ball valve 2 and 4. Close water now flow through the heat exchanger in Uniflow mode, and then switch on the centrifugal pump and set the hot water flow rate. And then adjust the cold water flow rate, and then wait until the thermo steady state condition is established. And then enter the temperature T1 to Tc and hot water flow rate. And then repeat step 3 to 5 by vary the cold water flow rate. And then repeat the experiment by adjust the hot water rate. And then switch off the heater, centrifugal pump and cold water supply after the experiment. Lastly, draw up the average temperature profile with varying the thermometer location in the same graph for hot water flow rate and cold water flow rate. And then refer to counterflow and Uniflow data. Plot coefficient of heat transmission with varying cold water flow rate. And then refer to counterflow and Uniflow datasheet. Plot mean heat flux kWm with varying cold water flow rate. This is it for our lab data. Okay, for the conclusion, for efficiency, heat exchanger are designed to minimize the surface area of the wall between the two fluids while minimizing resistance to fluid flow through the exchanger. They had observed that the loss, such as longitudinal conduction through the wall, heat inlet from surrounding, flow maldistribution, and decided to extend their study to understand more quantitative effect of heat in leak and axial conduction parameter on degradation of heat exchanger performance for 308K and 80-20K temperature range. For high flow rate, the heat transfer was dominated by the volume flow rate, and nanoparticles did not contribute to extra heat absorption. It means that at high flow rate, they found that the nanoparticle could not absorb more heat than water could counterflow heat exchanger. Besides, Christian et al. Had discussed about experimental investigation on the effect of a fluid flow rate on the performance of a parallel flow heat exchanger. The effect of fluid flow rate on the performance of parallel flow heat exchanger in an extent plate with regard to the thermal efficiency overall heat transfer coefficient, convective heat transfer coefficient, flow rate, and Reynolds number. Also the convective heat transfer coefficient increase with both Reynolds and Nusselt number, which increase the overall heat transfer coefficient. About review on heat transfer and separated heat exchanger energy saving is major matter in our global world, and heat exchanger is a very useful for energy saving. Heat exchanger is a piece of equipment built for efficient heat transfer from one medium to another without affecting the other properties of the medium. Okay, that's all for our group. Thank you.